Hello and welcome back, everyone. Into this module 4, chapter 1, where we're going to start with Arduino simulation. We're going to understand Arduino from the perspective of a hardware and also a software. We're going to see how you can learn, how you can get started, and how you can practice Arduino on a simulation software. You can, however, also purchase an Arduino if you want, but I would recommend using the simulation software for now. But in case you feel like you want to grow ahead in this line in this journey, buying an Arduino would be perfect investment. So I have a very good setup today because this is going to be a little longer session than usual. Okay, so I hope you have your water bottles with you to hydrate yourself, a notebook, of course, to write down everything, and lots of patience because this session is going to be a little longer. I'm going to start with absolute fundamentals. I'm going to explain you all the details, all the niches which are going to be there, and we're going to also talk about how you can understand and break down concepts of robotics in a much more simplified form, and how you can break down even a bigger system in a simpler form so that you can apply these logics as well. So lots of things to learn, lots of things to remember, and I'm very sure that you're going to have a lot of fun because this is a very interesting part, because this is the most interesting part, I should correct that. Yeah, and yeah, it's a lot of fun in Arduino, and let's get started with the main implementation of Arduino simulation in our softwares. So we are going to first of all start understanding concepts of Arduino, okay? And that's what I'm going to tell you on my iPad, and we're gonna jump into my iPad screen, which like is going to be like this. Okay. So now in this case, we are going to understand Arduino. Okay, Arduino in itself can be a little complex. So we have already talked about Arduino a lot, but right now in this video, I'm going to assume that you have zero knowledge of Arduino if you have not really watched any previous videos. So that's absolutely fine. We're going to understand Arduino from the conceptual and both the electronic point of view. Okay, so let's start with the name Arduino itself. Okay, so it's a small piece of hardware which is like this. Okay, the basic Arduino Uno R3. Arduino Uno R3. Okay, that's a standard version I'm talking about. Okay, it's about like 7 centimeter in width and 5 centimeter in length. Okay, about approximately. I'm not sure exactly how much is it, but yeah, approximately, like very very palm friendly. You can hold it in your hand. It's pretty easy to hold. Now, when you talk about Arduino in itself, okay, you talk about two things at the same time. Whenever someone pulls out the word Arduino, okay, it means you're talking about hardware plus software. Okay. If you use just the word Arduino, if you are specifying a particular model, then if you're saying, let's say Arduino Uno R3, that's definitely a hardware. Okay. And let's say someone is saying Arduino IDE, which is integrated development environment. That's pure software. Okay. Couple of things which are very important. This is the most important ones. Okay. Now that you have understood what exactly happens when someone says Arduino Uno R3 and Arduino IDE, now we're going to understand what exactly happens when you're talking about all of these concepts in a much more wider perspective. Okay. Now, so whenever you are talking about Arduino, what you are talking about is a microcontroller. Now, before we jump into Arduino, you need to understand a couple of properties of a microcontroller. Okay, couple of properties which are always there and which you should always remember as well, and it's going to help you a lot in the journey. Okay, so a microcontroller by default, okay, can perform single task at one time. At one time. Okay. Usually, when you talk about microprocessors, okay, I think I should draw a table. I think this would be very helpful for all of you. Microprocessors. Okay. So when you talk about microprocessors, then it's a different story altogether. Why? Because in microprocessors, you can perform multiple tasks at the same time. At the same time. Okay, that's very important. That the ability to have different processes at the same time is only available in microprocessors. Okay, that's why when you talk about Intel i7, Intel i5, Intel i3, all of these are microprocessors. They can handle multiple tasks at the same time. Now, when you're talking in terms of electronics, you don't say it as a task. You say it as a thread. Okay, a thread is nothing but a task. But when you have multiple threads, your processes are also known as multi-thread processors or multi-threading processors. Multi-threading. Very important for all of you to understand that multi-threading processes are the ones which are very important. Okay, the reason for why sorry, multi-threading processes are basically microprocessors, and they're not microcontrollers. Okay, very important that you know the difference, because it's going to decide a lot of tasks, a lot of problems which can occur into your system. And if you're finding a microprocessor versus a microcontroller for a particular application, you can understand this with this logic. Okay, let's take an example. Let's say you're building a laptop. Okay, in that case you cannot use a microcontroller, because eventually you would want multiple things to work at the same time. Okay, when you want multiple things to work at the same time, microcontroller cannot do that. So you cannot really buy a microcontroller. That's nearly impossible to work with as well. Okay, that's why you will always go with microprocessors. Intel i5, Intel i7, Intel i9, Xenon processors, Core 2 Duo, and even these days Mac have their own microprocessors known as M1s, M2s. Okay, so all of these things are basically microprocessors which are responsible for handling multiple tasks at the same time. Now, there must be, of course, something which is coming, which is the difference, right? So the major difference that again, apart from this, that goes is the cost. I forgot to write down the single thread part. Single thread, single thread, which means one task at one time. Okay, very important, guys. Okay, so cost. Okay, since microcontrollers can only do one task at a time, definitely by logic, by simple understanding, the cost is going to be drastically less. Drastically. Now, when I say drastically, it means like $5 or $10 max. Okay. Obviously, there are better ones which are like for $50 or something, but I mean, usually it doesn't really go above that. Okay. So, this is the price range that we're playing at. However, with microprocessors, it's very expensive. So, it's expensive. Now, when I say expensive, it's exponentially expensive. Exponentially. Okay. What it means, it's going to start from, let's say, $100. Okay, it can go all the way up to like, I don't know, like $4,000 just for the processor. Okay, so very expensive in terms of implementation, very expensive in terms of task handling, but very good as well, to handle multiple tasks at the same time. Okay, now what comes with the package is also very important. Okay, in a microcontroller, everything comes with the package. Okay, everything. Now I'll tell you what do I mean by everything. Okay, you should know what all everything is there in terms of electronics for a controller. Okay, and that's what we're going to discuss as well. You basically have a couple of things which are very important. You have a RAM. Okay, I'll tell about RAM in a much more technical detail as well. But for a lot of you, you know what is a RAM, so that's why I'm writing RAM. You have the controller or the processor. Processor. Oh, I mean controller. Yeah. So I should write controller. Yeah. Controller. The RAM, the controller, and the storage, all in one single package. Okay, it's going to be like one single small rectangular cube. Okay, and it's going to have everything. Okay, the one used in Arduino is known as 80 mega 328. Okay, so let me just write it down. 80 mega 328p. There is another one in the same microcontroller that's 80 mega 328a. That's basically at another side. I'll talk about it in the lecture, but don't worry. This is something that you should know. I know it's a lot of things to remember, but you don't have to remember all of these. The whole idea is to give you a holistic understanding of what happens between a microcontroller and a microprocessor. So it's going to help you in the long run. Okay. So I hope you understood 80 mega 328p. Okay. Let me take a sip of water. Hmm. So Intel series come into microprocessors, of course. And what comes with the package? Let's see what comes with the package. In the package, we just have the controller. Okay, we need to have a separate RAM, which is going to be external. We need to have a separate storage, which is going to be external. So everything is going to be external, and they're going to be connected via PCB or wires or something. That's how you connect them. But the main idea is that these things are going to be very different from the controller process part. Okay, so if the controller is going to be one, and you must have also heard about GPU, graphical processing unit. So you have GPU as well, which is also externally controlled. Okay, so nothing is in the central base. You need to have everything running on the sides. Okay, in a microcontroller, you don't have a GPU, so you don't have that possibility as well. Since you are performing only one task at the same time. And yeah, this is the initial breakdown. Okay, this is how you break down electronics in terms of microcontroller and microprocessors. Now, you need to understand, once you have started to break down this electronic concept like this, you are at a stage where you can understand pretty much everything that is happening around you. Let's start taking an example from a real world use case. Okay, I'll also give you some little test for you to figure out which one have you thought about this. Okay, let's say you're talking about microwave. Okay, microwave. Okay, the one which is used to heating the food. Heat. Yeah, heat the food. Yeah. So when you talk about microwave, okay, let's say you have to design the controller. So the task is design the controller. How can you do that? Pretty straightforward. You need to understand, do we need couple of, so you can answer a couple of questions. Okay, I would say, do we need multiple things happening at the same time? Do we have a cost budget? How reliable do we want? Okay, and then we talked about a couple of other things. Do we have this? Do we have that? And that's it. I think three questions more than enough. I think you can answer, even in the first two questions as well. I think third one is just a little cherry on the top. So I would actually mark it as, like a little cherry on the top as well. Let me just put out my markers. Okay, let me just take a red color one. Yeah. I have to, yeah, put it here. So that this one is okay. My bad. Yeah. So this one is basically an optional one. To go back to my pencil. Yeah. Yeah. This is an optional one. So optional. Okay. Now, when you talk about this, okay, let's say you want to answer this question. Okay, do we need multiple things at the same time? Not really. I mean, not at all. I won't say that. Okay, why? Because essentially speaking, you are either heating the food or changing the settings, or let's say you are changing the time. Some microwaves have time showing as well, and that's it. Correct, right? I mean, you have these three things. That's all. I mean, you don't have to do anything extra or anything over the top. So when you know that you just are going to like either heat the food at one point, change the settings at one point, or change the time at one point, you are more or less designing or building a system which is gonna be doing one thing at a time. Okay, that's one. Do we have cost budget? Yes, of course. Microwaves are very cheap. I mean, microwaves are the cheapest electronic items in the food industry so far when we talk about expensive food like machines. Okay. So obviously we have a budget. If you go to IKEA, okay, there is IKEA, by the way, in Bangalore and Mumbai in India as well. So if you go to IKEA and if you buy a microwave, I think we can get that for 4,000 to 5,000 INR. INR. which means it's approximately $40 to $50. Okay. Now you need to understand when you're talking about this price range, okay, this price range means that you need something which is going to be obviously budget friendly. Since microprocessors are going to start from like $100, it's not going to be possible for you to fit in this case. Now then you look into the fact that can we handle one thing at is there a way that we can handle one thing at a time? Of course, there is a way. We use a microcontroller. Okay, we don't need anything else. Now, since we know that we don't need anything else, we know that this thing is what we want. Our task is solved. Okay, we know that this is what is going to perfectly fit the situation, and we can cut down the cost. We can fit our budget. Everything works very perfectly. So our winner is basically, of course, microcontroller. Okay. Now I would want you all to take a pause. Okay, and now do solve this next task which I'm going to give, and pause the video. Okay, and then come back once you solve it. Okay, very important. So the task is to decide if we need a microcontroller versus microprocessors. My bad. Yeah. Oh, this is a pencil, this is eraser. Yeah. So, okay. In the case of car, 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 infotainment. Now, if you don't know what is an infotainment system, it's basically on the dashboard where you play songs, where you have GPS, where you have multiple things at the same time. That's where you have, the car infotainment system. Okay, I want to decide: do we need a microcontroller or do we need a microprocessor? And then come back after you have solved it. You can start your task now. Okay, I assume you have solved your task and you're back again. Okay, and now I'm going to tell you how do you solve it. I actually accidentally said it in the line itself that you have multiple things happening at the same time. So when you say multiple things, okay, it means that you are essentially going to use a microprocessors, of course, because essentially speaking, let's divide what all we do. Okay, we need to listen to music. Of course, I mean, everyone listens to music. I mean, there are people who don't listen to music, but mostly everyone listens to music. Do you have GPS? Okay, and you also have controls of the car. Now, when you are using GPS, you would also want songs to play on the background as well. Okay. And also, you might need to change the color of the lights or you want to open some doors or something. So, you need all of these things. Okay. All of these things happening at the same time. Of course, high end cars have more of these features, but low end cars are slowly and slowly getting all these features as well. But all of these things tell us that you are going to use a microprocessor. Now, let's talk about the budget situation. Okay. Do we have a budget? We do. But in terms when you're talking about building a car, the budget is obviously quite high. Let's say you even take the cheapest microprocessor, which is for let's say $100. Okay. In that case as well, that's not really going to bother you or not really going to bother the manufacturer as well. Why? Because, I mean, a car already costs so much. I mean, and $100 is not really going to bother the person at all. So you can obviously invest in such money, make a very good system and build a very good overall system for the user and the end experience. Okay. Now, when we talk about end experience, it's again very important to understand that both microcontroller and microprocessor have a very different end experience. Okay. When you talk about end experience, okay, in terms of microprocessors and microcontrollers, there is huge amount of difference. Okay, I'll tell you why. So let's say you have a microcontroller and then you have a microprocessor. When you talk about microcontroller, okay, you don't necessarily have the possibility of controlling, or building, or having a huge amount of a feature set. Okay, I'll give you an example. Okay, let's take the example that you need to build a system which is going to have a display where you can buy tickets. Okay, usually in the railway station you have systems that where you can buy tickets. Let's say you want to build that. Now, in that case as well, when you are going to work on buying a ticket experience, you would want it to have a really good display so that the people can read small text and everything, and it should be a little fast and snappy as well. Okay, you can, however, cut down the cost and use a microcontroller. Okay, and still get the same, still get something which is going to work. Okay, so it's going to be something. Okay, which means you can display some stuff. Okay, you can have like a touch functionality. It's going to be very slow for sure, because microprocessors will handle one refresh at one time, so it's going to be obviously very slow. But in case of microprocessors, you can speed it up very, like, a lot. Okay, so let's say your end user experience is going to be very smooth. Like, even the iPad that I'm writing on, okay, this one is really powerful. Okay, so that's why even my pencil and the iPad are working so seamlessly, right? That's possible because it has a microprocessor, okay, which allows it to have multiple things happening at the same time. Okay, when we say multiple things, okay, it also underlinesly say the end experience is going to be very beautiful. Okay, in terms of feel. What do I mean by beautiful? It means that the user is going to feel great about the experience. Okay, it's not going to be slow. It's not going to be sluggish. It's going to be very fast and very responsive. Okay, because you can handle multiple things at the same time. Okay, imagine when you're saying multiple things at the same time, it means that you are essentially giving the user the authority to have multiple things happening as well. Okay, so let's say you have a touchscreen experience. Touchscreen, you can do that, no big deal. Because touchscreen, what exactly is happens in a touchscreen? You have a screen. Okay, you have a lot of options. You can touch a lot of things and you can get the results out. Okay, and that happens with the iPad as well. When you have, when you like, even if I take this example, okay, of this thing, when I said this, okay, it's pretty responsive. It's very responsive. It's so smooth. That only happens because we are having a microprocessor. So multiple things can happen at the same time, and multiple things will give a user a very good experience. However, with microcontrollers, that is not going to happen. So that's why you would see microcontrollers being used in places where you don't have a display. Okay, usually it's a trick. Okay, you should know this. So microcontrollers, if you just want to guess, which one we should use, microcontroller, microprocessor, it's a very good guess if you understand how the end user experiences. Okay, so no display or heavy processes. I think I can give you one more example for this thing. Let's take the example of yeah, I think this one. So let's take the example of the AirPods. Okay, when you open the AirPods, you get a pop-up. You get a signal that the AirPods are being used. There is no display for this thing. Okay, now since there is no display, you don't need a microprocessor. You can use a microcontroller. That's why they're able to cut the cost and build them for comparatively very cheap. So the whole idea and this whole experience is that that you need to know what exactly you want the user to feel. If you want the user to feel very immersed in the experience, very much dive into the experience, then you definitely need microprocessors. But if that's not the case, then don't worry. Don't worry at all. Okay, let's move ahead. Now you understood microcontroller, microprocessor, and I'm glad that it's much more clear now. Okay, now you need to understand that whenever you will talk about microcontroller, microprocessors, there's another thing which is very important, is the type of inputs that you have. Okay, the type of inputs that you have. Now when we say inputs, it means the data which is coming in. Data coming in. Okay, I think my writing is a little bad. I'll try to write it better. Okay, data coming in. Now when I say data coming in, okay, it can be either from Ethernet port, so RJ45. Okay, it can be from, let's say, USB port. It can be from LAN. Okay, LAN is actually RJ45 only, which I should mention. So LAN is basically local area network. You can also have VLAN as well, which is like wireless local area network, which is, or wide spectrum local area network, which means you're basically connected to the internet. Then you also can have other port protocols as well. Okay, you can have CAN protocol, which is very popular in automotive industry. So if you're from automotive industry, you might have heard about this thing. You also have I2C protocol, okay, which is again very popular. So all of these things are there, and you need to understand that, since you are more or less in a situation where all the controllers or all the devices which are there are going to be communicating in some sort of way or the other, what you need to do, or what you need to understand, is the fact that all of these things and all of these control processes need to have something or the other which can interpret the data. Okay, data interpretation system is going to be there. Okay, interpretation. So, data interpretation. Sorry, guys, if you feel like my writing is really bad and the spelling mistakes are there. Okay, I'm trying to understand the concepts. That's much more important over here. So, data interpretation is very important. Okay. Now, when we talk about data interpretation, it means how your controller is going to break down the data into simpler packets, and how your data is going to be used in the microprocessor as well, or microcontroller as well. Okay. So, you need to understand if the data is breakable or not breakable. Okay. That is heavily decidable about the processing power. Okay, if your processor is capable, if it's powerful, then it's all good to go. Otherwise, it cannot really handle it. So I would want to dive into this thing, but I think since all of you have already like understood a lot of these things now, I'm going to dive into the practice, and we're going to actually take some practical hands-on onto the Arduino, and we're going to see how you can run Arduino on Tinkercad. So let us jump back, and I'm going to go to tinkercad.com. It's a website. Just go here, and it's going to load up. Login. Login from your personal accounts. Login with Google. Okay. Once you log into Tinkercad, you can see a lot of things which are here. A lot of things. Okay. Now Tinkercad is a full-fledged platform. Okay, which means it allows you to design things, use electronics, do a lot of things which are there. We're gonna do pretty much a lot of things, but I would want to start with circuits. So if you have an empty box over here, that's absolutely fine. You just need to click on circuits. Okay, and you need to click on a new one, and click on circuit, new circuit. That's it, and it's going to open up. Now, once you have your electronics over here, and you are over here essentially in your Tinkercad, you need to understand it's a simulation software. Okay, it's simulation software allowing you to do simulations. You have a lot of things over here which are present, and you can pretty much simulate anything. Okay, so I'm gonna add an LED over here. LED is nothing but a bulb. And now I'm going to add a battery. Okay, so now I have a bulb, I have a battery. According to physics, if you connect a battery to the LED, it's going to power it up. So anode in physics is basically positive, so I'm going to connect the positive to the anode, and and the cathode in physics is basically negative, so I'm going to connect the negative to the cathode. In chemistry, it's opposite, by the way. So when you start the simulation, you can say the bulb is glowing. Obviously, there's a warning which that says the current is too high, which is true because the battery is directly connected and there's no resistor. So we're going to fix that. We're going to remove this off. We're going to add a resistor, flip it like this, change the value to 220 ohm. That's like a very standard. Okay, so that's why I remember what exactly should be there. Make the circuit a little more cleaner. I like to make circuits cleaner when there are more components. It just looks much more peaceful to me. And then start the simulation. And there's no problem at all now. So what we exactly did is basically we connected a small resistor to an LED, and now it's glowing. If you buy these components in real world as well, you would get the same results. Okay, you would get you can get an LED. Okay, you can get a resistor, you can get a battery, and connect all of these things together, and you'll get the same results. Okay, nothing changes. That's the beauty of simulation. Basically speaking, you talk when we talk about simulation, you are more or less designing a system which is going to be exactly the same in real world as well, and that's why you call it simulation. Okay, perfect. Now let's add a switch. Okay, let's I'll take off this wire, and I would connect it like this and like this. When I start the simulation, nothing is happening. But when I press the switch, there it is going. You need to understand that in this switch in particular, you need to look for the terminals. So this is terminal 2A, this is terminal 2B, this is 1A, 1B. Okay. So you should not connect these two together. So let's say hypothetically speaking, you move the switch and connect it like this and start the simulation, it's always going to glow and the switch is basically disabled. Okay. We don't want that. That will only happen if you connect one to one different channel and second to a different another different channel. Now it's gonna work the way you want. Now you can get rid of the switch, add a slide switch now, so that you can keep the circuit hold it on and like this. Okay. Now let's see what happens. Let's start. And now it's on. Now it's off. On, off. Very easy. Very, very easy actually. So what we're doing over here is we are simulating real world components in a software. The way it works is since you have the properties of the components defined in the software, you can pretty much simulate all of these softwares very well. Okay. I'm going to tell you how you can even simulate a dimmer. Okay. So it's a little new, might be a little new thing for you. So whenever you like take example of a dimmer is nothing but a system which allows you to, dim the lights, if you want. So for that, I'm going to build this circuit. You can follow along, of course, if you want. You can connect this terminal to this terminal to this terminal. Now this terminal will go here. I'm going to start coloring the wires as well so that it makes it much more easy. Okay. I like planning it up. It makes it the circuit quite clean actually. I don't want the circuit to be messy. So I don't like it. Yeah, perfect. And now like this. Okay. We also need one cathode. So, or the negative one. Okay. So it's going to be black. And I'm going to take the negative one all the way here, all the way here, all the way here, and here. Perfect. Now let's start the simulation. Now when you increase this thing, you can see the brightness is increasing. Okay. And when you decrease it, you can see it's decreasing. Okay. The way it works is you are essentially balancing out the current so that whenever the current is going, okay, or whenever the flow of charges are going, it's you are regulating how much they are going into the LED. Okay, so you are essentially controlling the brightness. You can also monitor this thing. That's the magic part over here with the help of a monitor. Okay, so you also have monitors systems which will help you to do this operation. Let me check. Okay. So the crazy part is you can monitor this as well. So you have a monitor over here, a multimeter that you can use and connect to the LED. Okay. So I'm gonna connect one negative to the negative cathode, positive to the positive anode. This goes here, this goes here, black. Start, increase, 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 and increase. You see how powerful this thing is. So essentially speaking, what do? We added a couple of components. Okay, we simulated how it's going to work. Okay, we actually added a multimeter, which is going to tell us how it's going to show the voltages, and it is doing everything that we want. Now, this tells us a couple of things. This tells us how you can monitor, how you can create, and how you can build electronic circuits inside a software. All right. So now we have our basic circuit. Now let's move on and add a little more complexity into this thing, and we'll see how we can add that complexity. So first of all, I would request you to understand, a couple of rules which are important. Okay, coloring your wires is very important. So I'm gonna color these ones as well, and this one. Okay, this is gonna help you understand your circuit first of all much more better. Second of all, it's going to allow you to, figure out if there's a problem in the circuit. Okay. Now, I know a lot of you might be confused, why I place certain components the way they are placed right now. And it is totally okay. Okay. You are not here to learn electronics, but you're here to learn robotics. So I'm going to be focusing on that more, and we'll learn electronics about robotic components majority. Okay. Let me just close this. Yeah. So we'll actually move on and we will add a couple of things. Let's start adding motors. Okay, because that's one of these things which are very important in robotics. These are motors. So now motor has a very simple purpose. The main purpose of a motor, as we have seen motors in day-to-day life as well, is to make an actuation, to make things move. Okay, to perform certain tasks and to go from point A to point B. Now, of course, you cannot really build an actual robot inside this thing, but you can still build a lot of solutions on this platform, and that's what we're going to focus on. Okay, so motor is going to be one of the favorite topic of mine and favorite topic of you as well, because it's so interesting. We'll just understand how exactly do you control motors, okay, and how you can control the speed of the motors. So for this motor, I'm going to keep this switch. I'm going to add another one for this one. And now I'm going to connect the negative of the battery to the negative of this motor, like this. And then I'm going to connect the negative of this motor to the negative of this battery again. Perfect. So now we have negatives which are connected. Now for these switches, I'm going to connect one of the positives to the positive. I'm also going to change the color to red. Okay, so it's clean and easy. I'm going to move this button here, make it go here, go here, go here, and connect. And then I'm going to connect this part to this part. Okay. And then this part to this part. Perfect. So now we have our basic implementation done, where we are controlling these two motors with a battery. When we start the circuit, you can see both of these are 0 RPM. When we say 0 RPM, 0 means 0, of course. RPM is basically, revolutions per minute. So there is no spinning happening. When you press this button, you can see it says 286. When you press this button, it says 286. Okay, that's the RPM that the motor is rotating at. Okay, now you can see what we did. We controlled the motor using switches, and now we are essentially like controlling the spinning of the motor. Okay, like this and like this. Okay, now let's say you want to decrease the speed of the motors. The way you can do that is with the help of a resistor. Okay, I'm going to add this resistor over here. Okay. Or actually, I can add it here. It's much more easy. So I'm going to take this off, disconnect and connect it here, put it right here, put this one, and make a simple path for this thing, and that's it. Okay. Now I'm going to click on the resistor, change the value to 220. That's the favorite resistor of mine and electronics, of course, if robotics. So 220 ohm resistor. I'm going to copy and paste this resistor, paste it here, connect this one to this big guy. Yeah. So connect this to this guy. Okay, I think it's might have to delete this one. So you might see this problem sometimes. Tinkercad just sometimes freezes off. So it happens usually because sometimes we make a little complicated wirings and circuits, and then it's like confused because it's a web-based IDE or web-based development environment. You might need to refresh it once, and it should fix it. Yeah, it's fixed now. Okay, okay, perfect. So now we have a resistor. So when we start the simulation now and we press the button, it says it's running at 27 RPM. So it was something to 68 or 269, and now we're dropped to 27 RPM. Okay, that's a huge drop. You can change the resistance, decrease it to like let's say 1 ohm. Okay, and then when you press the button again, it's almost like at the full speed. Okay, you can decrease, you can set it to like let's say 100 ohms, and once you run this thing, it's running at 54 speeds, 54 RPM. You see, what you're doing over here is you're trying to understand and trying to control the speed of the motor with the help of a resistor. The bigger the value of the resistor, the slower the motor is going to be. Okay, that's how it goes. So what we're doing over here is we're essentially controlling the flow of electrons, and we're controlling the amount of electrons which are flowing, just to make sure that the motor is fast or slow. And this not only gives us an advantage that we can control the motor, this also gives us an advantage that we can decide how much speed do we want. Okay, I'll give you an example, a better example. Okay, so let's say we have 100 ohm for this one, and we get another one. Copy this, paste this. Okay, if the copy is not working, I will just add this. Add another resistor. Okay, copy this and paste this. Another switch. Connect it here. Connect it here. Change the color to red. Connect here. Change this value to let's say 1 ohm now. 1 ohm, very low. Okay. Change the color of this wire to red. And maybe let's fix it up a little. Yeah. Okay. So now when you start the simulation, if you press this button, it's going to rotate at 54 RPM. If you want to press this button, it's going to rotate at 274 RPM. You see what we did? We basically created two different pathways for the flow of electrons. And the way it works is that if you press A button, it's going to run at different speed. If you press the second button, it's going to run at different speed. Okay. When you're working in electronics, the similar kind of thing happens. Okay, you are essentially switching from one speed to the other in a let's say like a electric car or something. Okay, I'm going to automate this system so that you don't have to do this. I don't like to press two buttons. It would be nice if there was this one button. So let's just do that. So let's delete this, and add a slide switch. Okay. Now slide switch will do this exact same thing, but with a much more of an ease. Okay. So now you can connect these two here. And now if you see what I'm doing over here is essentially allowing the circuit to be like this. And then common one is going to go and move up till here and till here. Okay. This is what we got. Now, when you start the simulation now, of course, it's going to rotate, but it's rotate at 54 RPM. And when you're going to go this side, it's going to rotate at 274 RPM. You see, what happens is you are now just using one single switch to switch between two different speeds. Okay, that's the beauty of electronics. The more you plan and the better you plan, the better results you're going to get. Okay, so That's what we're doing. Okay, now I'm going to optimize the circuit even more. Okay, you might be thinking, how can we do that? I'll show you. So let's just get rid of all of these. Let's add a potentiometer and connect the center to this one. And now I'm going to add a resistor. Yeah, okay. So now in this case, I'm going to connect like this, and I'm going to connect like this. So now it's done. I'm going to change the colors. One to black, one to red. I think that's fine. I'm going to connect one of these terminals to the black line. I know a lot of you might be like really scared of what exactly I'm doing, but don't worry. It's actually pretty straightforward, and I'm sure after a little bit of practice, you will be able to do this as well. Okay, now when you start the simulation, it's at 0 RPM, but as you increase it, okay, so I think I know the problem. The problem is the value of the resistor. It's too high. Let's say we set it at 100 milliohm. Okay, now we are actually able to send something, but in this case as well, we actually have a lot of resistance, which is creating a lot of problem. The another way that you could possibly do is like you can reverse the polarity. That is sometimes helps as well, but essentially speaking, that's potentiometer. At some point you will find good values enough that are going to connect and allow the speed of the motor to be controlled via potentiometer. Okay, now over here the main understanding that I want to give you is that in electronics, different arrangements can result in different performance and different ease of use. Okay, you always want to figure out how much easy it is to use for a user, and how much easy it is for you to use it, and how much easy it is for anyone to use it, in matter of fact. Okay, and that's going to give you a deep understanding of if this is something that you want to apply or add to the system or not. Okay, now that being said, let's actually stop this simulation, get rid of all of these extra components, get rid of this component as well, this one as well, but I'm going to keep the two motors connected to the ground. And now we're going to add some other controllers. Okay, now you need to understand that all of these things or all of these power supplies are compatible. So even if I choose like a 1.5 volt battery and I take like maybe three of them, I think three of them is a good idea. Yeah, and I connect the positive to the negative, this positive to the negative. Okay, I'm gonna actually change the color in the end, and negative I put it over here, change the color to black, and then take the positive, change the color here to red. And now, if you see what I did is like I basically made a battery pack. Okay, connect three cells together, and this is the battery pack. When I started the simulation, it's running at 143 RPM. See, you see what happens. Basic principle of electronics are followed in the software. That's the beauty of it. Okay, you don't have to overthink on doing something. You don't have to overthink on okay, this is something which is going to go bad and everything. So you have a lot of space and room for implementing and building good software solutions and simulation solutions, I mean, for the user and for you as well. So you don't really need to buy all these components as well. Now let's say you want to add something else. Okay, let's say you want to add an RGB LED, which is going to be there. Okay, I think RGB LED is like way too easy for now. So let's talk about directions. Okay, now directions are quite an important topic. I'm going to get rid of all of these, and let me bring my favorite battery, 9 volt battery. Okay, I rotate this one this time. Okay, perfect. So let's connect negative to negative. This one goes black, positive to positive. This one goes red. And now this is essentially like a simple circuit. So the motor is going to run. We all know it. Okay. Now what we don't know is the fact that once you reverse the terminals, okay, then it's going to behave differently. Positive goes to the negative, and negative goes to the positive. If you see now that we have a minus sign over here, which means that the motor is spinning backwards now. Okay. So the way it works is we need to understand that the direction of the motor can be controlled with the polarity, or positive, negative symbols connected in which direction. That decides which direction the motor is going to go, and that is quite an important factor, I would say. After this is done, you need to understand that all of these simulations are simulations. Okay, they're not real world. What do you call it? They're not real world components. So when you buy a real world component, it might behave a little differently, not gradually, but a little. let me let me grab some water. Okay, perfect. So now that we know about this thing, we need to understand that okay, this is done, that is done. Put here, put this here. I like to make this beautified. It's just a bad habit, I would say. I don't know. I mean, maybe it could be a good habit as well. Yeah, perfect. So this goes here, and this goes here. Perfect. So now we have the circuit being set it up, which is a basic circuit currently, of course. Now, since we have the basic circuit up and running, we can definitely add more components, okay, and definitely add more structures to this thing, which is going to help us build a better platform overall. Okay, so now we are actually going to move forward and understand a couple of important things before we actually start implementing on motors. And the first thing that we're going to understand is motor direction and motor rotation speed. Okay, so two parameters which are very important. I'm going to jump back to my iPad so that you guys can understand what I'm trying to say. Okay, all right. Now we are back on our iPad screen, and as you can see, it's going to be quite an interesting part from here. Now you can see. Yeah, okay. The iPad was having a little bit of glitch. No, now it's fixed. Okay, so let me turn back to my pencil. It's cool. So we need to understand motors in a much more realistic way and how robots use motors. Okay, very important to know that how robots use motor and what are drives. Okay, you might have heard about 4x4 drive. Okay, or four-wheel 4 drive, which means when you take a car or a robot, of course, in that case you have a motor and a wheel on one side, second, third, and fourth, and all of them have their own individual drive shaft, their own individual motor basically. That's a 4x4. Okay, typically usually all cars which are not 4x4, they are actually 2x4, which means two of them are powered wheels and two of them are non-powered wheels. Now powered wheels and non-powered wheels are very important because they help you understand what exactly the robot is going to what is exactly is going to happen when the robot is going to take a turn. Okay, how robots are going to take a turn depends a lot on the powering of the motors. Okay, so in a typical robot, let's say if these two wheels are powered, which means these two have like what do you call a motor, then these two need to turn. Okay, turn, to make a turn. Okay, or they can do it like this, that one of them spins clockwise or one of them can spin anti-clockwise. So in that case, what would happen is you would have a rotation. Okay, but the problem is over here, you need to understand that rotation actually depends on a lot of factors. And one of the key concepts that you need to understand is the rotation angle. Okay. You need to see that if you have a small robot, okay, which is like this, and which has wheels like this and like this, and it has motors, one motor, second motor, and there's a free wheel over here which allows it to go anywhere it wants. This robot can take 1 point turning. Okay, 1 point turning means that let's take the center of this robot. About this center, the robot can take a turn like this. Okay, it's going to obviously take a little bit of offset turn because this point shifts to this point, because which is the point of contact. So about this point, you can rotate the robot at any direction you want. Okay, so that's how it works. If you take the example of a 4x4 wheel, okay, robot, let's take white pencil again. Let's take this one. Over in this case, what happens is that this point of rotation actually changes and becomes in the center. Okay, so now what exactly is happening is that the robot is going to rotate from the center. So it's going to rotate like this all together. Very important. Why? Because what happens is, if your center point of rotation is exactly at the center, you can do a 1 point turning. Okay, a 1 point turning means that robot does not need any extra space to take a turn. If you see over here, this robot is going to need a lot of space because it's going to move all these points all the way up till here. Okay, and it's going to do that about this point. Okay, so when this point is the center of rotation, the entire body has to rotate a huge amount of circle. It's going to make a huge circle. However, for this thing, it can stay at the same position and just rotate about its single point. So that is what drives, and that is what decides upon how a robot is going to move from point A to point B. And if you have a rotation, how the rotation is going to matter. Okay. Now let's understand how do robots rotate. Okay. If both the motors are moving forward, so there's like a table. I'll actually make a table. Okay, and then we have two columns first. Okay, M1, M2. I'm talking about this combination M1, M2. So two-wheel drive right now. Okay. So in this case, what happens is, let's say if M1 is on or forward, M2 is also forward, then robot is gonna go forward. Okay. If M1 is forward and M2 is backward, essentially it's gonna take a left turn. If M1 is forward, if M1 is backward and M2 is forward, it's going to take a right turn. If both M1 and M2 are backward, then it's going to take a reverse. Understood? Very easy, very straightforward. What happens is that you are telling the robot to essentially take either of the turn and either of the path, which is required, and these turns can be decided with this table. Okay, if you program the robot to have these things, you are allowing the motors to rotate this way. Okay, so you want the motor to take a forward turn or a backward turn. Okay, and that's going to decide if the robot is going to move forward, backward, left, right, however it is. In case of 4 by 4, let's understand 4 by 4 now. 4x4. Okay, my writing is a little bad. Okay, 4x4. Now, in this case, what happens is, since you have a 4 by 4 arrangement, you need to plan the groupings. Okay, usually in a 4 by 4 arrangement, what happens is this wheel and this wheel and this wheel and this wheel are present. Okay, and in this case as well, this wheel and this wheel are actually a single group. Okay, and this wheel and this wheel are a single group. Okay, now when I say single group, it means that the motors are internally connected together, so that whatever direction this motor is going to go, the other motor is going to go the same direction as well. Okay, very important for you to know this thing, because if you don't know this thing, then you would have a really hard time figuring out how and why the robot is doing the wrong things. It's better to understand this once and once for all. And this one is going to be like this, and this one is going to be like this. Now once you understand this thing, essentially speaking, exactly the same table that we drew over here, exactly the same table is going to take over the same path as well. So exactly this thing that we made, we are actually going to copy this and we're going to paste this. Okay, let me just paste this here. Paste. Yeah. So I'm not sure where the table went, but it should be somewhere here. Yeah. So essentially speaking, what happens is, if you talk about M1, M2, okay. So in this case, you can say that M1 and M2 are grouped together. Okay. When I say grouped together, it means they are actually like one single unit only now. So this one is M1. This one is M2. Okay. I'm telling you, the only thing that changes is the rotation point. Okay, so between a two powered wheel motor robot and a 4 powered wheel robot. In the real world, cars don't operate like this because cars don't have separate wheel drive systems. Okay, so they cannot really take like a single point turning. But if in future we have such cars, then of course they can take single point turning for sure. But right now they're not, as of 2023. So that is very important for you all to know. Okay, now that we understood what happens over here, we're going to understand a very deep concept. Okay, it's known as a motor driver. Okay, motor driver. We'll clean this. Any guesses you can think of? It's pretty straightforward actually. A motor driver is nothing but a control circuit which is not this size, actually a little longer and more like rectangle. Yeah. So it says a motor driver which can control motors. Okay, which can control motors direction, okay, and polarity. Now, polarity and direction for motors are essentially the same thing, but what you need to know and you need to understand that this driver basically can take signals from Arduino and then take actions according to the motors, okay, on the motors. So, technically speaking, what is going to happen is that the Arduino will tell the this driver, okay, driver, understand it like a car driver, okay, it will do whatever the school principal or the school management will say. It will just do exactly what they will guide them. So the model number is L293D, the one that we're going to talk about. L293D you can actually find on Google as well. L293D, it's a motor driver, which is a H-bridge motor driver, allows for two motors to be controlled at the same time. Of course, you can do it for four as well, but it's usually best for two. Okay, but the motor driver over here is essentially going to be the part player, which is going to make sure that the motors are rotating in the right direction or not. Okay, the good thing is that you can program this motor driver through Arduino. Okay, so Arduino comes here, and you can connect it to Arduino. And once it's connected, Arduino can send commands to this controller to make changes in the direction of the motor. Okay, of course we cannot really change the speed of the motors. That's another story for some other day. We need a lot of electronics for that. That usually happens, if you still want to know, that happens with MOSFETs. Okay, MOSFETs are the ones which regulate the voltage and allow you to change the speed and everything. That's a long story actually. So MOSFETs, we don't want to go to MOSFETs right now. We would actually stick to just this driver. Now, once you have understood what a driver is, this driver essentially allows for motors to be controlled. Okay. Now, when I say motors to be controlled, I mean that all the motors which are there connected to a robot can have their own single driver, or two motors can have one single driver. Okay. So L293D actually can control two motors at the same time. Okay, with the best performance. If you want, or if you're out of budget, you can actually add two more motors into this thing, but that would significantly reduce the speed of the system, and it's not really helpful as well. So it's better to buy like two motor drivers, and and then connect everything. Another thing is, these drivers are actually pretty cheap. I know I've been mentioning the cost, but I think it's very important for you to understand that in electronics there's a very strong correlation connected between cost and the output of the product. Okay, so I think these cost you like INR 100 rupees, okay, or US dollars. If you're talking about US dollars, then it's going to be like $2 or something. Okay, so one controller, a motor driver, is actually very cheap. So that's why people recommend buying a couple of them, so that in case you burn one of these out, you can obviously replace them. Very important. Now we have understood what a motor driver is. We're going to see a little bit of things in action, and then we will move ahead. So without any further ado, let's actually jump into the screen and understand all of these concepts on the Tinkercad as well. Okay, welcome back everyone. In this part, so we are on the screen now. We have understood what is a motor driver. Now we're going to check it up, okay, and we're going to understand what exactly does it do. Let me jump into the screen and share my screen real quick. Perfect. So now we have two of our motors, which were initially there as well. We have the power supply, which is there. Now, technically speaking, 9 volt is not really a recommended power supply for these small motors. These motors are known as BO motors. Okay, so BO motors. If you Google BO motors, you would actually come across these exact same motors, which are pretty cheap. But 9 volt is not really which is recommended for this, so we'll get rid of that. We would actually need 5 volt or 6 volt. We can make 6 volt with these batteries, so I'm going to make that off using this. These are AA batteries, which is each 1.5 volt. So the way you can increase the voltage to 6 volts is by connecting them in series. Okay, so that's what I'm going to do. Now in series connection, you basically connect one positive to the next negative. This goes here, this goes here, and now we need another one. Okay, perfect. So now we have 4 of them, which if you add 1.5 plus 1.5, 3 plus 1.5 is equal to 4.5 plus 1.5 is equal to 6. So we have 6 volts, which is absolutely perfect. Now, if you see, we have one negative here, which is gonna go here, and the other positive, which is here, and which can go here. Perfect. So now we are supplying 6 volts. If you run the simulation, it's running at the maximum speed possible, which is safe. Okay, safety is very important. If you can obviously run it on 9 volts, but that's not safe. It's not really like good for the lifetime of the motor. We want to be a little safe on the safe side. Okay, coming back to motor driver. Now we have the same motor driver as I recommended and is suggested. Now, before I jump into the motor driver in practical, you need to understand that motor drivers can be a little challenging for a lot of you when you are starting up. Okay, so I'm going to show you how does it look from the circuit as well. L293D. Okay, extremely popular package L293D. It looks like this. Okay, so usually these are packages. Okay, now when I say a package, it means it has a lot of electronics, but everything is packed inside this. Okay, so if you go down and you see the internal diagram, it has something like this. Okay, it has 4 transistors which are connected to switch on, switch off the motors in different directions. But since this is a package, what they do is they pack everything together into one single box. Okay, or single silicon conductor. Now this is all made of so if you cut it inside, I think maybe we can find some inside images. There might be some images from cut inside. Um, I think if you see for IC cut inside, yeah, it usually looks like this. Okay, the semiconductor or the silicon chip is actually inside, and all of these small wires are connected to the outside. Okay. Now, you might be thinking, why do we even do that? The reason why we do this is because it saves space. One, it makes sure that we can produce all these circuits at a mass rate. And usually, a lot of applications have a very certain or very defined purpose. Okay, so let's say you talk about robotics. Okay, all of the robots need one or the other similar kind of motor driver, and then you can use this package directly right away. Okay, you don't need to look for or build your own circuit again and again. You can just use this package. Similarly, when you talk about Arduino has 80 mega 328p. Okay, now this basically is a microcontroller. Okay, which means a lot of other applications would need the same thing. You can also find the smaller package of this thing. Okay, so if you look for SMD package, SMD is the small size version of this thing, which does exactly the same thing, but in a very small scale. Okay, obviously there are some limitation to this thing because of the small size, but most of the features are still the same. Now, what happens is that what in general electronics, what the trend is happening is that you try to miniaturize this circuit as much as possible, as small as possible. The reason why we do this is because we want to make sure that we get the maximum efficiency in the smallest form factor, and there is no way out other than this. Okay, so that's why everyone is behind how you can miniaturize all of these things as small as possible, and that's what we get. Okay, now a lot of talks here and there will come back to this thing, motor driver. Okay, now since we have understood from the previous section of this thing that you are going to connect the motor driver to the power supply and then to the motor, and then you can control the direction of the motor. Let me tell you how it's going to work and how it's going to look. Okay, so the simplest way to do that is just put a sliding switch. Okay, let me refresh this thing. Sometimes it doesn't work. It depends. Tinkercad is a little bit moody. Sometimes it's like, oh, I don't want to work today, so it just doesn't work at all. But yeah, what we're going to do is, okay, we have a connection in the network, which is not the case at all. I'm very sure the network over here is pretty strong, but I'll tell you until it loads. So essentially speaking, we are going to simulate what is going to happen inside the controller, okay, with the help of these 2 sliding switches. Okay, I'm going to connect one of the common terminal of this thing to the common terminal or the terminal of this one, positive, and then make a small node so we are not creating any sort of mess. Then connect the other one like this to this. Perfect. Okay, now we have this, and now what we're going to do is we're going to connect the negative to one side, and this also to negative. Okay, and now we're going to connect the positive to the other one. Okay, I think I did a little wrong. We need to cross the wire. Yeah, it's gonna go from here, go away, It's gonna go here. It's gonna go here. Okay. So one gets the positive, second gets the negative. Now, when you run the circuit, it goes in one direction, and when you flip the circuit, it goes in the other direction. You see what we are doing? We are changing the direction by changing two switches, okay? But the problem is this is mechanical. This is not electronic, okay? We need to manually hold these switches and change each of the direction so that the motor starts to move in a different way. Now, the problem with this thing is that you want to do two operations at the same time and you are not even doing it digitally. Let's say you want to do it with a phone app or you want to do it over the internet. How would you do it? You can't really manually make the switches move. That time we get this motor driver to function for us. Okay, so we are going to get rid of a lot of all these. Okay, let's get rid of this, keep this here. Let's connect the negative to output 1. Okay, and this connect the output 2 to the other one. Output 2, perfect. And then you need to connect the enable pin together. And this enable pin together as well. And then this enable pin together. I know it's a lot of circuit to remember, so you don't have to remember this. For me, it's like I've known this for years now, so I don't really need to recall this again and again. Okay, not orange, red. Okay, so all of these positive, and for this one, I'm going to make it positive, so red. This one is going to go black. Although there is no certain polarity over here, but still. Now, if you see, we are not using this section at all. So we'll leave this part. However, when you have to put in input 1, input 2, and these two. So if you see these two are ground. So which means they're going to connect to the negative one. Okay, ground electronics means that you are using the negative pole. Okay, so now you connect this. Okay, now you connect this and you change the color to red. Perfect. So now you can see that you have this system or you have the circuit which is looking pretty good actually. Okay, you have everything connected, you have all of these things connected, and if you run the circuit, nothing should happen technically, okay, because we haven't added any input. We are going to add the inputs now. So you take the push button, add the push button. Okay, it froze again, so we'll just do a little bit of refresh. So what we're going to do is we're going to add 2 buttons, and these 2 buttons are going to control the direction. So now you're going to understand what I was doing earlier was essentially like quite difficult, and what you're going to do now is going to be quite easy. And the reason why I say easy, because you can also control it from electronic signals as well, which means you can control it using Arduino, Wi-Fi, Bluetooth, anything. Okay, at the end, it should be like a digital signal. So now what we're going to do is we're going to add this push button over here. Okay, and I'm going to keep this button over here. Okay, now what you need to do is you need to connect this terminal to this one and this terminal to this one. Okay, and make it here. Make it here. Perfect. Now we're going to connect these 2 terminals with each other. And then we're going to connect this to the positive terminal or the enable one. I know it's a little scary, that's why I'm doing it so neatly. So any one of you who is like kind of scared understands that what exactly is happening over here. It's not really complicated once you start to understand what exactly is happening. I'm going to change this to red. Change this to red. And change this to, let's say, blue. And change this one to, let's say, pink. And now when you start the circuit, you see 0 RPM. But when I press this button, it says minus 159. When I press this button, it says plus 159. You see how cool that is? The entire thing, we actually like did something which was extremely complicated, extremely distributed, and now we are able to do it at the same time with just 2 switches. Okay. Now another thing that you could do is you can connect this motor to this motor as well. Okay, now this froze again. I'm telling you, Tinkercad is like getting an overload these days because of its extreme popularity. So you might have to refresh it. And I'm not saying that it's bad. All I'm saying is like, even on the best laptops, it can still fluctuate. And when I'm saying best laptop, because I have the most spec'd out one. So I'm not showing off, but I'm just saying this. If this laptop can crash, any laptop can crash. So don't worry. Okay. So now we'll go back here, and we're going to connect the negative to this negative. Okay. And now this positive to this positive. And change the color, black. Start simulation. Okay. Okay, some problem. Refresh, start simulation. Oops. So I'm not sure why this is happening. But I think more or less it's a server error from these folks' side. Okay, now it's working. I think they don't want this to connect to this. I don't know why. So, no problem. Essentially speaking, if you connect two motors in real life together, then they're going to rotate in the same direction, and that's the whole purpose of this thing. But now we're going to move ahead, and we're going to understand what heck exactly happens when you connect this motor to the other side. Okay. Before I jump into that, you need to understand a couple of things. Okay, you need to understand this thing that the power or the current in a voltage or in a motor divider circuit or a motor driver circuit is very distributed. Okay, when I say very distributed, it means that you are more or less going to come to the fact that, okay, no matter what exactly you're doing, you are eventually, or you are more or less going to have this problem that your circuit might have an overload. Okay, in that case, you need to plan your battery packs. Okay, right now I am using this 4 battery packs, which is not the most optimal one. In real life, it's always advised to use a DC power supply, which can be like a power bank or something, which is much more reliable because of the current capacity. Of course, you can increase the current capacity of this thing with a simple modification that I'm going to tell you right now. Okay, which you will like, of course. So what I'm going to do is I'm going to create another 6-volt battery using another 4 sets of batteries, and I'm going to connect this to this, this to this, this to this, and now you are going to connect this negative to the second negative, or the first negative, I would say. And then you connect this negative to this negative, and then you convert this to red, then you convert this to black. Okay, now what would happen is that you still would get 6 volts, but the current will increase. I'll show you how you can see it. If you get a multimeter and you connect it over here, connect the negative to this thing, positive to this thing. Okay, positive. Okay, and then you start it. You still get 6 volts. Okay, if you go to current mode, you can't really, get the accurate current, because this is not how current is measured. You usually watch or measure it across a wire. Okay, so I think I'm going to do that for you all. But this is set to voltage, and I'm going to take a wire, put the negative here, because when you're measuring current, you don't need to mind about the negative and positive. All you need to focus is on it, that it's across a wire. Okay, so this and this. Okay, and when I start it, you set to current mode. Okay, now it's not driving any current, but if you use it, then it's going to start to drive current. Okay, and that's what happens over here. You essentially can measure the current using this thing. Okay, and that's what this current is all about. This thing is all about. You can also measure it much more effectively if you connect this terminal to the other side. Okay, which is equivalent to the battery pack, of course. I know. And if you see over here, it says minus 6 ampere because it's connected oppositely. But if you start using the current, okay, using the motor, okay, we have a little short circuit on this thing. Let's close it. Let's cut it. Let's start it. Yeah, start it and it's working, and stop it, it's working. So essentially speaking, what you do is you basically plan your circuit in a much more effective way, and you more want to make sure that you have certain plans with the motor planning as well. Okay, if you have one motor, then just one battery pack is okay. If you plan to build like this, but if you need like more current, then it's better to go with this sort of circuit. Now, once you have a circuit like this, when your motors are working and everything is like in shape, you can now start to plan for the other motors as well, or the other one motor as well. Okay, and in this case as well, what I can do is I can add another motor driver and have more motors as well. Why I'm telling this to you? Because right now what you are doing is essentially you have a digital circuit that you can replicate as many times as you want. Okay, now when I say replicate, it makes a lot, it opens quite a lot of door. Because if you see, technically speaking, if you just have one signal, then you can send the signal to a lot of other devices, and all of these devices will can do the same thing. Okay, you can even add an LED over here. Okay, let me actually do that. And you click on this LED. Okay, it's kind of like a little lagging today. I'm not sure why. Okay, probably just in Europe. Sometimes it's pulled down. So what we're going to do is we're going to add two LEDs. Both of these are going to show us the direction. Okay, so let's say you're building a robot and you don't really know exactly what to do, and how would you know the direction of the motor. Okay, now we have it. So you can have two LEDs which are going to tell us the direction of the motor. Okay, now I'm going to put one of them here and the second one here, and I'm going to change one of the colors to, let's say, yellow. Okay, yeah, okay, my bad, it's yellow here. Perfect. So whenever it's going to go forward, it's going to go not yellow, I think green was makes sense. Okay, if it's going to go forward, it's going to say the green LED is on, and the other one is going to be the red LED is on. Okay, 1 2. Now if you remember from the previous videos, we were using 220 ohms, 220 ohm. Similar for this one. Okay, both of them are done. Now we can connect this anode to this to this, and for this one the opposite. When you start the code, nothing happens, of course, but when you press this, it's going to move. Okay, now I connected the wrong colors, so I'm going to just change the color from here to red, and this one to green. So once you move backward, it says red. Once you move forward, it says green. You see, very easy. Okay, the best part about this Tinkercad solution or the software is that you can do so much things over here without actually buying any component. Okay, you can even add more controls to this thing. Let's say you want to add the brightness of these LED bulbs, you can do that. But usually in any industrial or robotic application, you have something like this which tells you the direction of the motor without actually looking at it from your bare eyes. So it's very sure that which direction the motor is moving, and that's kind of like very important as well, I feel. You don't really want to mess up with the motor direction on your final stages. So I'm going to just connect this to this and this to this. Okay, now we're going to start the simulation, and we have everything working perfect, very smooth as well. Actually, you can also have like other things which, if you want, all of these other stuff where you can have like a vibration motor. So in case you're making like a phone device or something like that, you can still use it to build something interesting. And now here we go again. So it's a little lagging today. Usually it doesn't, but no problem. Maybe I am recording too much of videos on this machine. Okay, let's close this. Okay, yep, we have this. Perfect. Now we can see that we have these two things running. Now you can also connect the other motors over here in case you want to control it from this thing. But you can potentially add a vibration motor. I was suggesting positive goes here, negative goes here. When you start, okay, and this is something new, kind of an error. Okay, now it's moving. Yeah, it is moving. Okay, So now we are going to connect the positive here. Here. Start. Yeah, it's probably just with a couple of components that they are having problem, which but due to which they are saying that there's a problem. But usually, what happens is that the vibration motor also starts to spin. Of course, it's going to spin in the clockwise and the anti-clockwise direction if you change the polarity or negative to positive, positive to negative. But essentially speaking, what you're doing is you are building the same sort of relation over here as well. Let's come back to my camera and let's discuss this further as well. Now, what you have understood is that there is a fundamental principle of how do you control motors, and there's a fundamental principle of what motors actually can do. Okay, so either they can be stopped, either they can be running in forward direction, either they can be running in the backward direction. That's it. There are only three conditions which you can achieve, and all of these conditions are achievable through the motor driver. Okay, and motor driver can also support, obviously, like there's fourth condition as well when both the signals are coming. So essentially, let's say someone is like smart enough and pressing both the forward and the backward button, what is going to happen in that case as well. Now all of these things and more, essentially we're going to cover in the next class, where we're going to talk more openly onto this controller, the motor controller. But trust me, if you have never bought a motor controller, if you have never bought a electronic circuit, I would highly suggest buying this controller for yourself. It's only $100 or something, and $100 is pretty cheap in India, I'm very sure about it. And yeah, the main reason is that because you can essentially try out so much more stuff with this motor driver, control motors, control even like window shades as well if you have like motor based window shades, and so much more. I think I have done so many projects with this motor driver. It's just tremendous because it acts as a relay or like a small device which can convert like small signals into big actions. And I feel that this is pretty much like one of the most powerful controllers out there, which everyone uses or at least has used once. So if you plan to buy one, feel free to get one from Amazon or something. But apart from that, I think that's all we have for today. And yeah, I'm going to see you in the next one. Till then, happy learning. Peace.